Hello there.
Hello indeed. So, finding
I'm
zeros.
gonna really keep going
Yeah, sure,
after
might as
that
well.
start. Okay.
Finding zeros, but now doing it on a calculator because Mrs. Stevenson over here, Fancy Pants Stevenson, could probably factor this guy. I can't.
I honestly can't. I'm gonna tell you straight up. Well, I don't want to, is really the more important thing. What we would do is we'd stick this into the calculator. The way you know that this is probably a calculator situation, for one thing, the decimals are a pretty good indication. Normally with decimals and fractions, factoring is not a very good idea. And then if we graph it, we graph this on Desmos, the online graphing calculator, who are not paying me to say that. And this is what we came up with. Well, for one thing, if you don't understand how to find the zeros on your calculator, we're going to give you a link that just shows you that. But it's pretty easy to do, especially since we've done max and min. So we're not going to stick it in right here to distract you. But what we can see is clearly, oh, maybe we could have factored this, because clearly there's a 0 at 2.
Right there too, yeah.
I mean, that's pretty clear that there is a 0 at 2. What is up with my pin thickness? Why did the pin go all crazy?
I don't know.
Okay, x equals 2, and then clearly something is happening here that we just can't see well enough from this graph. So remember the trick of the box.
Yeah, the box is going to be really handy here, or even just zoom in, but on the origin, because that's where it looks like something's happening.
Yeah,
so
since
I'm doing
it is
that,
on the origin,
I'm doing that right
might work
now.
out well. I personally like zoom box better. I feel like I've been jaded by zoom in and zoom out too many times to trust them.
It's entirely possible.
There's a point where you say, fool me once, shame on you, fool me twice, shame on me.
That is correct. What you have just stated is a correct thing.
Are you finding that?
I'm zaboxing right now.
And when you zoom into that box, like this part in the middle that it looks constant, you got to understand, it has to be a super strange looking function to ever end up with a constant. Like, it is going down.
Mm-hmm.
Okay, that whole time. Like, it evens off a little bit, but we wouldn't actually call that constant, right?
No, it is not constant, although it
it
be
looks
falling
like it.
at a very, very small
very,
rate.
very small, minuscule amount of falling. Like, we're talking constants, what? We get constants with absolute value functions, and that's it, right?
Right.
And that's only if they're really, really weird. So, are you going to find that 0?
I'm working on it.
Yep.
Are you going
to find the 0?
Yep. My calculator is in super slow-mo right now, and it looks like that 0 is at negative 0.1.
So x equals negative 0.1?
Yeah.
Is that the only decimal?
That's what it shows.
Why? Oh, okay. And that's the only 2 places where we go through. Now, I mean, that's all there's to it.
That's all there is to it. Now, also, keep in mind that how many zeros could we have on this particular problem?
We could have had as many as 4.
But we only had 2, so you will always get zeros in, for these kinds of problems in pairs, I think is safe to say, for even polynomials.
I think that's true. For even polynomials, you'd always get them in pairs.
Mm-hmm.